Good morning. And today, economics class, session number 1. Okay, welcome back. We are discussing the measures of dispersion, right? Measures of dispersion, in which today we want to discuss about two important aspects. I hope the screen is visible, right? Okay, is there a trouble in the screen? You're able to see the screen properly, right? Okay, fine. And yesterday we completed up to here quartile deviation. Quartile deviation. I discussed about how to find the quartile deviation and the range. Range and the quartile deviation are the two concepts that what we discussed yesterday. Okay, hope these equations are clear for you. Okay, so the last paragraph should be read. I want to finish this quartile deviation. Okay, so if the entire group is divided into two equal halves and the median calculated for each half, you will have the median for a better students and the median of weak students. So we discussed about how to find out the mean deviation, right or not? I mean, quartile deviation, not mean deviation, quartile deviation. So that is useful to find out. Okay, the difference between the numbers and the difference between the lowest one and the highest one. Okay, so we are able to find what is the basic difference between these numbers. Okay, is it a huge, it's a big number, we are able to understand that the trouble between or the difference between the lowest and highest is too high, so disparity is huge, difference is huge. Okay, so that's what the usefulness of finding out of this range and quartile deviation. Similarly, suppose you have data about income of people of a town, median income of all people can be calculated. Now, if all people are divided into two equal groups of rich and poor, median of both groups can be calculated. Okay, so we can use this method. Okay, quartile deviation. So quartile deviation will tell you the average difference between the medians. Okay, so quartile deviation basically we are using to find the average difference between the medians of these two groups belonging to the rich and poor. For example, the rich and poor here from the median of the entire group. So quartile deviation can generally be calculated for open-ended distribution and is not unduly affected by extreme values. So we completed that quartile deviation. Okay, next we are moving to the next topic for we people here, measures of dispersion from average. So first of all, we want to find out the average here, then we want to find out the dispersion there. Okay, so here we want to go back to the previous chapter, measures of central tendency. Measures of a central tendency, where we studied about how to find out the mean, median, and mode. Mean, median, and mode, direct method, indirect method, like that various methods we studied, and we want to apply those things here. Okay, so we are reading here, page number 78, topic number 3, measures of dispersion from average. So recall the dispersion was defined as the extent to which values differ from their average. Okay, so extent from which the values are differ from the their average and the difference between average to the lower limit and the upper one. Okay, that's what the dispersion here. Range and quartile deviation are not useful in measuring how far the values are from their average. So range and quartile deviation is not that effective to find the difference between the minimum and maximum from the average, so from their average. Yet by calculating the spread of values, that's what the dispersion of values, they do give a good idea about dispersion. So the range and the quartile deviation will give an idea. Okay, but cannot say the exact figure related with the average and its the lower limit and the higher limit of that particular data. So two measures which are based upon deviation of the values from their average are mean deviation and standard deviation. So we are using two different methods to find out the difference between the lower limit and average, upper limit and the average. So we are using two different techniques here. One is mean deviation and standard deviation. Mean deviation and standard deviation. Okay, so first of all, we are going to find out the mean deviation. Here, since the average is a central value, as we studied earlier, averages are basically considering as the central value, right? Okay, since the average is a central value, some deviations are positive and some are negative. Some are negative. If these are added as they are, the sum will not reveal anything. So with this negative and positive data, if you are adding all these data together, that will not give an exact idea about that particular group and its average. In fact, the sum of deviation from arithmetic mean is always zero. Okay, just underline that. The sum of deviations from arithmetic mean is always zero. Look at the following two sets of values. Here you can see two sets of value. For example, here set A and set B. Set A and set B, 5, 9, 16, and 1, 9, and 20. Okay. So the central value is 9 here, right? Yes or no? The difference between 5 and 9 and 9 and 16 comparatively lesser than 1 and 9 and 9 and 20, right? Yes or no? Clear? Okay. You can see that the values in set B are further from the average and hence more dispersed than values in set A. Set A there. You just observe here. Okay. It is not farther, it is further. Okay. It's a tongue slip. I should be thinking and laughing like anything. I should. Okay, fine. Let it. You can see that values in set B are further from the average and hence more dispersed than values in set A. Set A. Just observe that clearly. You can find that. Calculate the deviation from arithmetic mean and sum them up. What do you notice here? Repeat the same with the median. Just calculate that. You can comment upon the quantum of variation from the calculated values if you find. So this is the thing. Basically, we are able to find the difference between the lowest value and the highest value and the average. Okay. So mean deviation tries to overcome this problem by ignoring the signs. So negative values will be there. Okay. Clear or not? So if you are using these negative values and positive values together, it will not reveal the real difference between the average and the lowest value and average and the highest value. Okay, so we are using this method. What is that? Mean deviation. Mean deviation tries to overcome this problem by ignoring the signs. So in mean deviation, we are ignoring the signs there. We are not adding or not including the negative signs here. Negative signs, right? We are excluding that, not giving any importance for any particular signs here. Signs of deviation, that is, it considers all deviations are positive values. Clear? All differences are positive values. For standard deviation, the deviations are first squared and averaged, and then square root of the average is found. We will do that. Okay, we shall now discuss them separately in detail. Okay, so first of all, we are moving to the mean deviation. Okay, so mean deviation. Okay, suppose a college is proposed for students of 5 towns. Here, suppose a college is proposed for, okay, going to construct, okay, for the students from 5 different towns. Town A, B, C, and D, A, B, C, D, and E, 5, okay, which lie in that order along the road. So all these towns are lie, okay, along the road. So distance of towns in kilometers from town A and the number of students is these towns are given below. You can see in the table here, right? So 5 towns are there for town A, town B, town C, D, and E. Okay. So first of all, we are going to find out the distance of B, C, D, E from town A. Clear? So from town A, there are 90 students. Town B, there are 150 students. The difference from town A is 2 kilometers. Okay. Coming to C, there are 100 students are there in that town. The distance from town A is 6 kilometers. Clear? Next one, town D, there are 200 students are there and the distance from town A is 14 kilometers. Next one, town E, the last and final one, town E, there are 80 students. The difference or distance from town A is 18 kilometers. 18 kilometers. So you can see total number of students is 620. 620. Okay. Now we are going to find a place to construct the college, right? So we want to take one thing into consideration. What is that? want to reduce the distance or want to create a distance for each and every town almost equal. We want to choose a town. So if you are choosing town A, what is the problem here? What is the problem here? Town E, students from town A want to travel 18 kilometers. D want to travel 14 kilometers, like that. So it is not that favorable for the students in town E and D and E. It's not good. Okay. So coming to the case of our state, you can see what is that? What is the problem? So our state capital, that's a Thiruvananthapuram, right? Right or not? So the people from the southern states are able to reach there easily. There can each sorry. Okay, each those southern districts, the people from that districts easily they are able to reach Trivandrum, right? Okay, now what about the central Kerala? Central Kerala want to travel nearly 300 kilometers, right? Yet or not? And what about the people from Malabar region? They want to travel more than 500, nearly 600 kilometers to reach the state capital. It is not favorable for them, right? Right? So think, if you are constructing the capital, okay, or what we can, the legislative house in Ernakulam, think about that. Is that favorable for the southern districts and the same time for the northern districts, right? Both these people want to send almost all the, or spend almost all the same to reach the capital, right? If Kochi or Ernakulam is the capital of our state, Kerala, right? Clear? So that giving equal opportunity for both these groups of people from the southern districts and the northern districts. Okay, so like this, you can observe. Okay, now if the college is situated in town A, for example, we are analyzing this possibilities. Okay, now if the college is situated in town A, 150 students from town B will have to travel 2 kilometers each, right? Clear? How many students are here? 150 students are here. So all these students want to travel nearly 2 kilometers every day to reach this college. So total 300 kilometers of traveling. Okay, because 150 students are there to reach the college. The objective is to find the location so that the average distance traveled by students is minimum. So what is the objective to find out the deviation here? Okay, find a place to construct the college. Okay, then we are able to reduce the distance of traveling. Okay, so you may observe that the students will have to travel more on an average if the college is situated at a town A or E. If it is E, also problem for the students from A and B. Clear? They have to travel the same kilometer. Okay, 18 and 14, right? Yes or no? The same problem will be there. Okay, here on an average, if the college is situated in town A or E, if on the other hand, it is somewhere in the middle, they are likely to travel less. Okay, so if the college is located or it is constructing somewhere in the middle of, okay, these towns, I mean A, B, C, D, E, we are able to reduce the distance of traveling there. So mean deviation is the appropriate statistical tool. So we are using mean deviation to find out these differences between the towns and to select a particular place to construct the college. Okay, so mean deviation is the appropriate statistical tool to estimate the average distance traveled by the students. So mean deviation is the arithmetic mean of the differences of the value. So mean deviation is the arithmetic mean of the difference of the values of their average. The average used is either the arithmetic mean or median. So find out first of all, you want to find out the average. So we are using arithmetic mean or median. Okay, since the mode is not stable. Okay, so mode we are not using because it is not a stable. Okay, so you want to calculate and to find it. The homework for you. Want to find out mean, median of this particular data, mean and median. Okay, so next one here, activities here, calculate the total distance to be traveled by students if the college is situated at town A, at town C, or town E, and also if it is exactly halfway between A and E. You have to find out that. Next one, decide where in your opinion the college should be established. If there is only one student in each town, does it change your answer? Okay, another question. You have to find out the answer for these two questions. Hope this idea is clear, right? This idea is clear or not? The only thing you want to find out the average, mean and median, and find out a place where you want to construct the college. Okay, that place is able to reduce the distance of traveling for all the students in that particular series. Clear? Clear? Okay, just try it. Next one, moving forward. Calculation of mean deviation from arithmetic mean for ungrouped data. First of all, we are moving for the ungrouped data. Ungrouped data, direct method. So hereafter, AM, that is arithmetic mean. Okay, first of all, there are number of steps are there to find out the mean deviation. Deviation. First of all, we want to find out the arithmetic mean of that particular set of data. Okay, arithmetic mean. Next one, difference between each value and the AM is calculated. All differences are considered positive. These are denoted as D. Clear? Clear. So D is absolute. Okay, D is absolute without any signs there, right? So this positive. That's what these two vertical lines denotes. Okay, D is a absolute value, no negative one, right? Clear. So next step, the aim of this difference called deviations is the mean deviation. So last finally, okay, the arithmetic mean of this difference is called deviation in the mean deviation. So equation is, the formula is, okay, mean deviation is equal to sum of D divided by N. Okay, here D is absolute value. D is a absolute value. Clear? So MD, mean deviation, is equal to sum of D divided by N. Okay, we are going for an example here. Example 3. Calculate the mean deviation of the following values. Here, observe everyone carefully. Page number 79. Example 3. Calculate the mean deviation of the following values of 2, 4, 7, 8, and 9. Okay. What is the equation to find out the arithmetic mean in direct method? Sigma x divided by n, right? Yes or no? Yes or no? Then calculate that. How the 6 came? Arithmetic mean is equal to 6. How it is? Can you prove that? Sigma x divided by n, right? What is the n here?
Sum of all observations by 5.
By 5. Very good. Okay. Sum of all the observations here. 2 plus 4 plus 6, 7, 5. Sorry. 2 plus 4 plus 7 plus 8 plus 9. It is 30, right? Right? Calculate. Yes. 30. 30 divided by n. N is 5. So we got a 6 here. So AM is 6. AM is 6. Back to the previous chapter. Okay, back to the previous chapter. Here, to find out the arithmetic mean in direct method, AM is equal to sigma x divided by n. Okay, so what is sigma x here? 2 plus 4 plus 7 plus 8 plus 9. Okay, so answer is 6 plus 7, 13 plus 8. 21 plus 9, it is 30, right? Observations, how many are there? 1, 2, 3, 4, 5. So 30, right? Got? Okay, so AM is 6 here. AM is 6. AM is 6 here. So we got AM here. Next one, the values. What are the values here? Observation 2, 4, 7, 8, and 9. Okay. 2, 4, 7, 8, and 9. Want to find out the difference from the arithmetic mean. Okay. For each of these values, the difference between 6 and 2, it is 4, right? We are not going to find out any negative values here or positive values. So all values are positive. Just understand that. Okay. So it is absolute values. That's what I already told you, that the D is in between two vertical lines there. Okay. So first of all, 2 minus 6. Okay, it is 4. Next one, 4 minus 6, 2. 7 minus 6, 1. 8 minus 6, 2. And 9 minus 6, it is 3. Got? How you got that one? Understood or not? First of all, we want to reduce. Okay, we want to find out the difference between the values or the data provided and the arithmetic mean. Here we got already the arithmetic mean is 6. So difference between 6 and 2, difference between 6 and 4, difference between 6 and 7, difference between 6 and 8, and difference between 6 and 9. We wrote that. Here it is 4, 2, 1, 2, 3. AM is 6. And the sum of the D here, absolute value 4 plus 2 plus 1 plus 2 plus 3, that is 12. That is a 12. What is the equation for finding out the mean deviation? So equation, it is a sum of D divided by N, absolute value. So bar x is equal to 12 divided by 5. The answer is 2.4. Got or not? The idea clear? So the mean deviation of this group data, sorry, ungrouped data, it is 2.4. 2.4. Clear? Clear or not? So average difference between these numbers, it is a 2.4. That's what the mean deviation. Okay, just go for an exam, homework. I mean, not homework, classwork. Just to find out a simple numbers I will give you. Okay, so do it. 6, 4, 5, 15, 20. 6, 4, 5, 15, 20. Make it fast. 6, 4, 5, 15, 20. Okay. Find out the mean deviation. First of all, what do you want to do here? Find out the arithmetic mean of this data. Ungrouped data, right? What is the AM? What is the AM here? Tell me.
10.
10, correct. Then, want to find out the difference. How the 10 came?
50 by
Arithmetic
5.
mean. Of course. 6 plus 4, 10, 10 plus 5, 15, 15 plus 15, 30 plus 20, 50. Number 1, 2, 3, 4, 5, 5. So answer is 10. Good. Good one. Then apply that. Find out the difference between this 10 and all these datas. Informing you, there is no need of using negative signs. Clear? No need of using any negative signs here.
Mean deviation is 6.
Yeah, mean deviation is 6. Fine. Correct. All of you got the same answer? Everyone check your answer. Anyone got any other numbers there? Any other numbers? What about Aparna? Is that 6? The answer is 6?
Yes, sir.
Okay, Anat, Anthony, is that 6?
Yes, sir.
Mr. Karthik already sent. Amal Raj, got that answer? What about Ashish Benny?
Yes, sir.
Yes, the same. Okay. Shubham, Atul, Elvina, Pavitra, Sharath, Anjo, and Hanna, please turn on your cameras. Please do that. Okay. So I hope this thing is clear. This idea is clear. How to find out mean deviation for ungrouped data. Ungrouped data. Going for one more example. Calculate. Okay. It is 150, 200, 250, 200, 250, 750, okay, 100. Come on, calculate. Okay, one more data I will give. 50, okay. Is this necessary to arrange this data into ascending order here? Tell me, is that necessary? No, right? Come on, fast. Got? What the AM here? Okay, correct Aishwarya. What the mean deviation? Okay. Come on, just send your answers there first. Let me check it. No need to say the answer, just send that answer to me. Let me check. Not only arithmetic mean, you have to find out the mean deviation, MD also, okay? Sorry, not MD, MD. Ashish Benny, what is that Ashish Benny? Just check it one more time properly. Adding all these numbers together, the data what you got, it is too high there. This is wrong. Calculation is wrong. Just check that. This is a simple calculation, right? Ashish. Okay, correct. Karthik. Elvin and Anju CB AM is correct. What about MD? So what is the answer to find out AM here? What is the method we are using here? So 150 plus 200 plus 250 plus 750 plus 100 plus 50. The answer is 1500, right? Yes or no? 1500. How many observations are there? 1, 2, 3, 4, 5, 6. So 1500 divided by 6. Answer is 250. Okay, so AM is 250. Okay, then you can do it easily, right? You got the AM there. What's the trouble? Mean deviation, Annette, it's wrong. Mean deviation. I want to find out the difference between these digits and the arithmetic mean. Arithmetic mean. So what we will get here? So difference between 150 and 250. What is that? 100 plus 200 and 250, 50. Okay, next to 250 and 250, it is 0, right? No difference. 750 and 250, 500. 100 and 250, 150. 50 and 250, 200. Right? Got all these datas? Got all these datas? So 150 plus 500. Okay, 650 plus 150. What is that? 800 plus 200, 1000, right? Yes or no? So you got 1000. Then what do you want to do here? 1000 divided by how many observations are here? See, in this equation, divided by the observation 1, 2, 3, 4, 5. Here it is 5. So in the question, it is 6. So 1000 divided by 6. What is the answer? What is the answer there?
66.6.
66.
166.
Yeah, 166. Correct, Anila. 166.6 something will be there. Right. So answer is correct. Okay. So everyone got the same answer? Same answer? Okay. So that is the mean deviation here. Mean deviation. Okay. Back to the chapter. Write 1, 2, 3 homeworks there and find out that for tomorrow. Okay. Number 1 homework. Set 1. Okay. Set 2. Okay. Set 2. Set 3. Set 3. I will read it. Set 1, 20, 150, 300, 233, 522, 31, 45, 61. Set 2, 38, 18, 20, 170, 131, 220, 560, 321. Group 3, 30, 50, 70, 80, 1111, 25, 4, 3, 2, 8. Right? Okay, so keep these equations in your mind and complete the homework and submit it. Next one, a mean deviation from median for ungrouped data. So first of all, we used arithmetic mean. Next, we are using a median to find out the mean deviation. Median. Okay, so using the values in example 3, Okay, so same values we are going to use here. What are they? It is 2, 4, 7, 8, and 9. Okay, what are they? 2, 4, 7, 8, and 9. Same data we are using. Okay, from the median can be calculated as follows. Calculate the median, which is 7, the center value, right? The center value is 7 here, right? So median means we want to rearrange that in ascending order. It is already in ascending order, so we can select the central value here. 2, 4, 7, 8, 9. So central value is 7. So median is 7 here, right? Got 7. Okay. So calculate the absolute deviations from median. Denote them as D here. Okay. Absolute value. Okay. Find the average of this absolute deviation. It is the mean deviation. The first case we find out the arithmetic mean by using the calculation. And the second one, median. We find out the median of this set of data here. That is the central value. It is 7. It is a 7. Okay, mean is 6 and here median is 7, central value. Okay, so we got it. Next one, we are applying that. We are finding out the difference between the median and these frequency, I mean the observations here. So 2, 4, 7, 8, 9, the difference between the 2 and 7, it is 5. The difference between 4 and 7, it is 3. Difference between 7 and 7, it is 0. Difference between 7 and 8, it is 1. Difference between 9 and 7, it is 2. So you want to find out the sum of D. Okay, what is that? 5 plus 3 plus 1 plus 2, that is 11. 11, right? Clear? First mean, the second method is with median, So sigma D divided by N, the answer is 11 by 5, 2.2 is the mean deviation here. Clear? 2.2 is the mean deviation. Okay, so we will discuss this in the next class. So complete the homework. I hope these ideas are clear for you, right? Yes or no? Okay. Okay, everyone. Thank you very much. We will meet in the next class. Thank you.